Hey guys, today we're gonna solve the problem 258 add digits from Leetcode. This one is supposed to be easy, at least I would say the first approach. Second one a little bit trickier. And what do we need to do is that we have a positive integer num, and we need to repeatedly add all its digits until the result has only one digit. So let's take a look at the example to understand how it goes. We have an input in here 38, so if we have an output of 2, so why 2? Point is, if you add 3 and 8, 3 plus 8 is 11. 11 is not a single digit number, so we continue the process till we have only one single digit number, 1 plus 1, which is 2, and since 2 is a single digit, we return it. So how can we do that? For the first approach, I will go with recursion because I find it to be quite straightforward, I would say. So let's do it this way. First condition is we test if we have a single digit number, obviously. So if num is strictly inferior to 10, well, we do nothing fancy, we just return the number. Now, what happened to other cases? To the other cases, we said we're gonna go with recursion. So we're gonna need to call again the function we are creating add digits, but what do we put as arguments? So here is just a mathematic, I would say, rule. If you want to separate a number in, say, blocks, you can basically divide it by 10 and add the modulo of 10. So if I write it down, just so that you understand a little bit better how it looks like this. So why is this formula right? Take the input, just to help you, 38. Divide 38 by 10. Okay, it's 3.8 obviously as a decimal, but if you want the integer value, you will take the lowest nearest integer, which is 3. So here for the first block, num divided by 10, you have 3, which is a single digit actually. And then you add the modulo of the number, modulo 10 of the number, which is basically the remainder of the division. So 38 divided by 10, we said it's 3.8 in decimal, but it's 3 plus 8 for the remainder. So obviously this will be 8. Now what would happen if you have more than 2 digits? Obviously you're gonna say, so say we have 320. 320 divided by 10 is 32. So the first block will be 32. It's not a single digit, but do we care? No, we don't care. Why? Because we are doing recursion. So before going to this, the 320 modulo 10, obviously, since 320 is divided, I mean, you can divide it by 10, the remainder is 0, so this one is going to be 0. So here we have 32. We're going to call again 32 on add digits, and since it's not inferior to 10, we're going to do the same operation. We'll have 3 plus 2, and we'll have 5, and this is what we should return. So this formula is fine, it's just that we are doing recursion, so it's going to take a little bit more time. And if we run it, it's good, and we submit it. Yeah, I have lots of submit, and there we go. So this one is working fine. Now the other solution, to be honest, the other one I checked the solution because I got no idea, and this is fine. So we are using what is called the digital root. So this is a formula. What it simply says here is say that if you have a number n, okay, and the number is equal to 0, well then the digital root, sorry, 0 if the number is 0, which makes sense, I guess. And if a number is a multiplier of 9, so say 9, 18, 27, whatever that you can divide by 9, then the result will be 9, which makes sense because this is this was a little bit a trick, I would say, back in the days in school. And if you want to know if a number is divisible or divided by, you can divide it by 9. You add the digits of this number, and if they are equal to 9, then it means it's basically you can divide it by 9. And in this case, the digital root is obviously 9 because this is how you check it. And finally, if a number is different from 0 or is not basically divisible by 9, what do? You return the n mod 9. So this would be the result. So why n mod 9, n modulo 9? This seems to be basically they put it out of there. So why is this the case? Why n mod 9? So basically they are giving you, so why n mod 9? I mean, where is this coming from? So it's, to be honest, if you read it, take a pen and paper, it's pretty simple. I mean, seriously, there's nothing difficult. You just need to obviously know a little bit divisions and reminders. But the fact is, you have a number and you can divide it as base 10 number, basically. So d0 plus d1 multiplied by 10 plus d2 multiplied by 100. So we want to have a formula. So what we do, we generalize this and we go to k. And the point is, I mean, if you have a number like, I don't know, 11, obviously it's 1 plus 1 multiplied by 10, which is 10 plus 1, which is 11. So here, then what do we do, basically? The point here is that we want to get the mod 9 out. So how do we get this one out? So basically we're doing this a little bit reverse, and we're gonna simplify this, make it a little bit more complicated to simplify the whole thing. Simply put, all the 10 to the power 2, 10 to the power k can be simplified, right? If you look at those examples, 10 is 9 plus 1, 100 is 99 plus 1, 1000 is 999 plus 1. So you have always a constant plus 1 that you add at the end, and you always have the factor 9 that you can add up front. And then you have this number that changes, which is basically 1 repeated k times, where k is the power 10 to the power k. So if you have 1000, k is 3, meaning we have 111, 3 times 1. Okay, so if we put those observation into the n, which is the number, the digit, so instead of putting 10, we put 9 plus 1, then 9 multiplied by 11 plus 1 till the end. So now how can we simplify this, right? You just take the 9 out of all the parentheses. You can put it as a factorial, okay? You take the constant out, so you get d0 plus d1 multiplied by 1 plus d2 multiplied by 1 plus dk multiplied by 1, which is d0 plus d1 plus d2 till dk. And then if you put 9 as a factorial, basically as a multiplier, I'm not sure how to say in English, sorry guys, it's not my native language, but you get the 9 in front, and what do you get? You get 9 d1 multiplied by 1. You get 9 11 multiplied by d2, right? 9 101 111 multiplied by d3, etc., etc. Okay, so this one is a little bit annoying. How do we remove it? Okay, here's the trick. We remove it by multiplying this whole thing by mod 9. So if we multiply on both sides of the equation by mod 9, we get n multiplied by mod 9, and then we get this whole parenthesis multiplied by mod 9, and this whole second one multiplied by also mod 9. So 9 multiplied by mod 9 multiplied by this whole thing. Thing is, 9 multiplied by mod 9 obviously is 0. So all this guy here, this whole long parenthesis, will go out, and we don't have it anymore. So we are down to exactly this result, d0 plus d1 plus dk mod 9. And there we go. This is exactly what we want. Once we have this, it's very simple, okay? So we're gonna put those in motion. Let's do it. So if we have the num that is equal to 0, we return, we said 0, or the num, whatever, it doesn't matter. Else if num, we said modulo 9, we return, equals 0, so we return 9. As simply as that. And finally, if basically, what do we have? In all other cases, what do we return? We said we return n modulo 9. So normally this should work fine, but let's give it a try. Yeah, this was missing. Obviously, this is better. N doesn't exist. Okay, not bad. So if we try to submit it, let's see how it goes, and it works fine. Just a point on the solution. Here they are saying that though two last cases could be merged into one. Okay, so how can you merge those into one, right? Basically what they did here is very simple. Just gonna write it here. So they are saying n mod 9 is equal to 1 plus n minus 1 mod 9. Let me remove this because it's a bit annoying and wrong. Okay, so how does this work basically? Well, the fact is n mod 9 is equal to n minus 1 plus 1 mod 9. Yeah, exactly. Minus 1 plus 1 is 0, but this will help us solve it. So which is also equal to, now we get the 1, we get it out of this parenthesis. So we're gonna get n minus 1 multiplied by mod 9 plus 1 multiplied by mod 9, right? So what is 1 multiplied by mod 9? So this is pretty simple. Actually, when you have a division, you have always a result or a number. You write it like that: b multiplied by the quotient plus the remainder. Okay, so if we say 1 equal 9, I mean 1 divided by 9, you can write it in this form where q is a quotient and you have the remainder. The fact is 1 divided by 9, if you do the calculator, the fact is 1 divided by 9, what it is. Good question, is 0 dot something, I don't know, whatever. Okay, so 1 divided by 9, what it is? 0 dot something, who cares? The point is, this will be an integer lower to 1, bigger than 0, so obviously we take the integer value, I mean the decimal number, sorry, and we take the integer value, which is basically 0. So in this case, q is going to be equal to 0, yeah, and basically we're down to, okay, so 1 divided by 9, what it is? It's a decimal number, 0 whatever xyz. The point is, for the quotient we want the integer value, so it's 0. Okay, it's not going to be 1, it's going to be 0. So if we go back to our equation there, we have 1 equal 9 multiplied by 0. So let's write it down just to make it easy. Multiplied by 0 plus the remainder. So in the end, r equal 1. So we get the remainder, it's equal to 1, right? So we said everything here just to say that 1 modulo 9 is, and sorry, not multiplied by, obviously, is 1. And once we have this information, then we get the formula. Okay, that's it. So that's how you solve this one. Okay, so now what are we gonna do? We're gonna test it, okay? Having the solution is good, having the test is even better, and the tests here, I guess, are pretty simple. If you have any more tests in mind, just leave a comment. But in all cases, let me grab a terminal because this is not supported by Leetcode, I guess. Maybe for the premium, who knows? And yeah, should be good. So let's see what we have here. Here I have two files, or one file, which is basically the add digit file. And in this file, I have the solution here. And basically what we're going to do, we're going to test this function. Okay, I'm using vimgo. So let's create a different file and let's create a test file. Add digits test. Go, I guess, and let me make this one a little bit bigger and open it. Okay, so we have those two files. We have the function to the right, and we have the test to the left and the test to the right. So let's create a test function and call it test add digits, right? It's not bad, and it's gonna use the testing package of Go. So let's just do that. Well, I have Vim Go, so it imports directly the packages, but you should import testing if you need it. And what we can do, well, the easy approach, or the naive approach, I would say, you can test values one by one, and you can say what I want is, for example, the result that I want for, I don't know, the number 38 is 2. So let's put it like that, just as such you understand. And what I got, this is where we're going to do the testing, is add digits 38, which should gives us back 2, right? And we're gonna say if we don't get what we want, let's throw an error and say got what did we get? We got yeah, we got this, and we want this, and there we got want, and we save it. So test success, just to show you, go test -v, and this is successful. This is not bad. Now we can test just this is right, so let's put 37 for example and test it. So if I test it, I got a fail. I said I got a want 2, so this is pretty neat, right? Now if we want to add more cases, we can do them on a single basis, but we don't want to do that. We want to do a test driven, I don't remember what's called, TDD approach. Let's put it this way and have a couple of values. So what we will do, we'll create basically a slice of struct where we define the values that we want to have tested, right? So we first define a name. The name will be the name of the test, of each test. So it's more user friendly, I would say, or more colleague friendly. And then we're gonna get an integer, which is want, which is also an integer. Yeah, like that is better. And we're gonna define those values. So name, the first one, what is name? Name is testing. Let's do something not crazy. Testing is 0. We're gonna test 0. What do we got? What do we get with 0? We get add digits 0. And what do we want? We want 0. Makes sense, I guess. Let's copy those. And here, what do we got? We test 9. I'm testing a single digit basically. I'm also testing, well, I choose 9 because it is a single digit, but it is also divisible by 9. So we call the function add digits with 9, and what do we want with 9? We want 9, obviously. And now we test, I don't know, 38, and here we replace with 38 and we replace with 2, right? This is what we want. So we close the bracket, and now we can loop through those for underscore because we don't really care about the index. For TT in the range of number test, I guess. What do we have? If tt.get is different than tt.want, we're gonna throw an error, right? So let's throw an error and say same thing as before, get want and beautiful. We should be done. Let's try to build it just to see if there are errors. Undefined want, undefined, yeah, of course, because I was looking at the other one. So now it should be better. Yeah, it's good. We can test it. Test success, just to show you how it looks like. You know what, I will show you what this looks like with a mistake, so it's more useful. Let's put 8 here just to simulate a mistake, and we're gonna go test, and there we go. So that's it for this Leetcode. Thank you very much, and see you later, guys.